Okay, this is the Unit 9 preview for the test. Objective 1 is trig ratios. I want you to be able to identify the following trigonometric ratio. So if I want to find the tangent of C, I'm going to come over to C, and that's going to be my theta. That's my angle. And directly across from that angle is 4, and 4 is going to be my opposite side, so I always want to go ahead and label those. Here's my right angle, so my hypotenuse is across from the right angle. So there's my hypotenuse, and that leaves 3, which is right next to the angle, the adjacent side. Now, for my trig ratios, we've been using SOHCAHTOA, so I'm going to write it up here, SOHCAHTOA. That's to help us remember our trig functions, and since I want the tangent, I want to go ahead and use tangent is opposite over adjacent. So my tangent of C is equal to my opposite side, which I've labeled 4, over my hypotenuse side, which I've labeled 5. So the tangent of C is 4 over 5. Cosine of R. So R is now my angle. That's going to be my theta. And just like number 1, I'm going to identify my sides. So directly across from my theta is 5. That's my opposite side. Here's my right angle. So across from there, that is my hypotenuse. And then next to theta, that is my adjacent side. This time I want the cosine. And cosine is adjacent over hypotenuse. So the cosine of R is equal to my adjacent side, 12, over my hypotenuse, 13. For 3 through 5, I want to find the missing side or angle using trigonometry, and I want to round to the nearest tenth. So again, I'm going to find my angle, which is 72. That's going to be my theta. Directly across is the opposite side, but I don't have any links here, so I don't want to label it. That makes x my hypotenuse because it's across the right angle, and that makes 6 my adjacent side. So again, using SOHCAHTOA, I want to determine which trig function is going to be best to solve this problem. And since I have adjacent and hypotenuse, I want to look for adjacent and hypotenuse in SOHCAHTOA, and I can see that the cosine function would be best. So I'm going to have cosine of 72 degrees equals adjacent 6 over the hypotenuse x. Typically, we would cross multiply and divide at this point. However, during class and in example 2 of our interactive notebook on missing sides and angles, we discovered that when I cross multiply and divide, what really happens is my cosine and my x switch places. So to save some work, x is equal to 6 over the cosine of 72. Okay, so what I want to do now is I want to grab my calculator and I'm going to turn it on. And always check to make sure it is in degree mode. This one is not, so I'm going to make it in degree mode. That will greatly affect your answers. And now I'm going to go back to the home screen, and I am going to type in 6 divided by cosine of 72, and I get my answer. 19.4. It does say round to the nearest tenth, so it's 19.4, and that's going to be my x. Okay, my next problem, number 4, 51 is my theta. Directly across from theta is 14. That's my opposite side. Here's my right angle, so x is my hypotenuse. So based on SOHCAHTOA again, let me move my calculator. I have opposite and hypotenuse. So looking at SOHCAHTOA again, I can see I'm going to be using the sine function this time. So sine of 51 degrees is equal to opposite 14 over hypotenuse x. Okay, again, I see my x is in the denominator. which means I can switch places with the trig function. So I have x equals 14 over the sine, not x, that's going to be 51. Okay, so bringing back my calculator. Okay, now I'm going to type in 14 divided by sine of 51. Enter, and my x is going to equal 18.0 since I'm rounding to the 10th place. Okay, number 5. Okay, here's my angle. That's actually my unknown. So there's my theta. And again, across from theta is 8. That makes 8 my opposite side. And that makes 20 my adjacent side because I don't have anything across from my hypotenuse. So since I have opposite and adjacent, I want to go back and look at SOHCAHTOA. And that looks like I have opposite and adjacent with the tangent function. So I'm going to write the tangent of theta. Theta is my unknown. That's equal to opposite over adjacent, which is 20. This time I'm solving for theta, so it's not the same as 3 or 4. I have to do the inverse tangent. So that cancels out tangent. We talked about that with the law of exponents. And whatever I do on one side, I have to do on the other. And what that does is that cancels it out because tangent to the inverse times tangent equals 1. So that leaves me with theta. Bringing my calculator back over, I'm going to push the blue button first for the second. Then I'm going to press tangent because right up here in the blue, there is a tangent inverse. And then I have my fraction 8 over 20. And I get my angle measure, 21.8. So 21.8 is my angle measure. And theta equals that 21.8 degrees. Okay, give me a moment to move it on up. Okay, so now we have using special right triangles and angles of elevation and depression to find the missing sides, and we're going to find x and y using trigonometry, and again rounding to the nearest 10th. So here's 30 is my theta, that's my angle. That makes 14 my opposite side, and that makes x my hypotenuse, and that makes y my adjacent side. So this time I have to find both x and y. So using SOHCAHTOA again, and again that's just the mnemonic we've been using in class to remember the trig functions. I need to find x. I'm going to go alphabetically first. So x. So I have opposite and hypotenuse. So I'm going to look for O and H in SOHCAHTOA, and I see that with the sine. So I'm going to set up a sine of 30 degrees equals opposite 14 over hypotenuse x. And again, I see my x's in the bottom, which means I can switch places. And I get x equals 14 over the sine of 30. Now I'm just going to grab my calculator. And I'm going to type in 14 divided by the sine of 30, and I get 28. So that means my x side is 28. And then I'm going to come back and set up a different trig ratio for y. And y uses opposite over adjacent. Opposite over adjacent means I'm going to use my tangent function. So tangent of 30 is going to equal 14 over y. And again, I see my y is in the bottom, so I'm going to switch places with the tangent. And I get y equals 14 over the tangent of 30. And that should be a 14. And then come back over here to my calculator. And I'm going to type in 14 divided by tangent of 30. And I get my side length, y is equal to 24.2. Number 7, I have to find x. And I don't have any angle measures this time. But what I know from the problem is that if this is x and this is x, that makes it an isosceles triangle. And that makes it a 45-degree triangle. 45, 45, 90. So if I label one of the angles, here's my theta. That would make this x opposite. And that would make 18 the hypotenuse. And since the x's are the same, I really only have one problem to solve. And I'm using opposite over hypotenuse, which looks like is going to be the sine function. So I'm going to set up sine of 45 degrees equals opposite x over hypotenuse 18. Okay, this time I'm going to put my sine over 1 to create my proportion, and then I'm going to cross multiply. So I'm going to multiply 18 sine of 45 and equals cross multiplication of the other direction, x. So in my calculator, I type in 18 sine of 45, enter, and I get my answer. 12.7 is equal to x. And since I have two x's, they are both 12.7. Okay, number 8. Brian's kite is flying at the end of 72 meters of string. If the angle of elevation to the kite measures 70 degrees, how high is it above Brian's head? We do have to draw a picture. So here I have a kite. That kite string is 72 meters. And it makes a 70-degree angle with the ground. And I want to know how high is it flying. So I want to know this side. That means my theta is 70, which makes x my opposite side, and it makes 72 my hypotenuse. So if I look back up here at SOHCAHTOA, opposite and hypotenuse is again sine. So I'm going to set up sine of 70 degrees equals opposite x over hypotenuse 72. I'm going to complete my proportion by putting 72 over 1 and cross multiply. So I'm going to have 72 times the sine of 70 equals cross multiply x. Let me bring my calculator back over. And I have 72 times the sine of 70. And I get my answer. It's 67.6 is equal to the x. So the kite's flying 67.6 meters above Brian's head. Okay, this will be the end of video 1. Please stay tuned for video number 2 to continue the preview.